Instant coffee is designed to deliver speed and convenience, but behind those lightweight crystals or powders is one of the most complex beverage manufacturing processes in the food industry. What begins as freshly roasted coffee beans must be ground, brewed, concentrated, frozen, dried, broken, classified, and packaged, all while preserving aroma, flavor balance, and solubility. Every granule must dissolve instantly in hot water and recreate the sensory experience of brewed coffee as closely as possible. And today on The How Factory, we're stepping inside industrial coffee plants to see exactly how instant coffee is made, from brewed beans to freeze-dried crystals. The story of instant coffee dates back to the late 19th century, when inventors sought a way to preserve brewed coffee in a shelf-stable form. Early versions were crude and bitter, but they proved the concept was possible. As demand grew during wartime and with the rise of global food distribution, instant coffee became a strategic product. Over decades, advances in extraction, drying, and aroma recovery transformed instant coffee from a utilitarian substitute into a refined, mass-produced beverage consumed worldwide. The process begins with raw coffee beans. Most instant coffee is made from Robusta beans, which are higher in caffeine, more economical, and produce a stronger brew that holds up well to processing. Some blends include Arabica for aroma and flavor complexity. Incoming green beans are inspected, cleaned, and sorted to remove stones, defective beans, and foreign material. Consistency at this stage is critical because flaws are amplified later in concentration and drying. The beans are then roasted in large industrial roasters. Roasting develops flavor through complex chemical reactions, including Maillard browning and caramelization. Roast profiles for instant coffee are typically darker than for retail ground coffee because darker roasts extract more efficiently and produce stronger soluble solids. Temperature, airflow, and roast time are tightly controlled to achieve a uniform result across tons of beans per batch. After roasting, the beans are rapidly cooled to stop the roasting process and prevent overdevelopment. They are then ground using industrial grinders. Grind size is carefully selected, coarser than espresso but finer than typical drip coffee. The goal is to maximize extraction efficiency without producing excessive fines, which can clog brewing systems and introduce bitterness. The ground coffee moves to large-scale extraction systems, often referred to as percolators or extraction columns. These are massive stainless steel vessels arranged in series. Hot water flows through the coffee grounds under controlled temperature and pressure, extracting soluble compounds such as caffeine, acids, sugars, and aromatic oils. Unlike home brewing, this process is designed to extract nearly everything soluble from the coffee. Extraction typically occurs in multiple stages. Fresh water contacts partially spent grounds, while more concentrated liquor contacts fresher grounds. This countercurrent process maximizes yield and efficiency. Temperatures can exceed those used in household brewing, pushing extraction further while carefully avoiding excessive bitterness. The result is a strong coffee extract, far more concentrated than anything brewed at home. Once extraction is complete, the spent coffee grounds are removed. These grounds are not wasted. They are often dried and used as fuel, compost, or raw material for other industrial applications. Meanwhile, the liquid coffee extract continues forward for concentration. Before concentration, aroma recovery becomes critical. Many volatile aroma compounds are lost during roasting and brewing. To preserve them, manufacturers capture aromatic vapors released during extraction. These vapors are condensed and stored separately in sealed systems. They will later be reintroduced to the finished product, restoring aroma lost during drying. The coffee extract now undergoes concentration. Removing water before drying improves efficiency and product quality. Concentration is typically achieved through evaporation under vacuum. Lower pressure allows water to evaporate at lower temperatures, reducing thermal damage to flavor compounds. The extract thickens into a coffee concentrate with a much higher solids content. At this stage, the concentrate resembles a dark, viscous syrup. It contains all the soluble coffee components that will eventually become instant coffee. From here, the process can diverge into two main drying methods: spray drying and freeze drying. Freeze drying is slower and more expensive, but produces higher quality instant coffee with better aroma and structure. This is the method we're focusing on. For freeze drying, the concentrated coffee extract is first cooled and then frozen. The liquid is spread into thin layers or droplets and rapidly frozen at very low temperatures. Freezing locks the coffee structure in place and prevents separation of components. The frozen coffee becomes a solid matrix of ice and coffee solids. The frozen coffee then enters freeze dryers, also known as sublimation chambers. Inside these chambers, pressure is reduced dramatically and gentle heat is applied. Under these conditions, ice does not melt into liquid water. Instead, it sublimates, transitioning directly from solid ice to water vapor. This process removes water while preserving the original structure of the coffee solids. Freeze drying is slow and energy intensive. The process can take several hours to days depending on batch size and equipment. However, the advantage is superior flavor retention. Because water is removed without high heat, delicate aromatic compounds survive and the porous structure left behind dissolves quickly in water. Once drying is complete, the result is a fragile, foamy slab of dried coffee. This slab is broken into granules using gentle crushing systems. The goal is to produce crystals of uniform size without excessive fines or dust. Particle size affects solubility, appearance, and consumer perception. After crushing, the granules are sieved and classified. Oversized pieces are crushed again, while undersized fines may be recycled or blended carefully. Uniformity is essential. Consumers expect instant coffee to pour smoothly and dissolve evenly without clumping. Now comes aroma reintroduction. The captured aromatic oils and vapors from earlier stages are carefully sprayed back onto the dried coffee granules. This step is performed in sealed environments to prevent aroma loss. The reintroduced aromas bind to the porous coffee structure, dramatically improving smell and flavor when the coffee is rehydrated. Quality control is constant throughout production. Samples are taken to measure moisture content, solubility, particle size distribution, color, and aroma intensity. Sensory panels evaluate taste, bitterness, acidity, and aftertaste. Even small deviations can affect how the coffee performs in a cup, triggering adjustments upstream. Once approved, the instant coffee moves to packaging. Packaging must protect against moisture, oxygen, and light, all of which degrade coffee quality. Glass jars, laminated pouches, and metal tins are common formats. Packaging lines operate at high speed, filling, sealing, and labeling thousands of units per hour. In many cases, packaging occurs under inert gas atmospheres such as nitrogen. This displaces oxygen and extends shelf life by slowing oxidation. Date codes and batch numbers are printed automatically, ensuring traceability from raw bean to finished product. Behind the visible process lies extensive sanitation and safety control. Coffee extract systems are cleaned regularly to prevent microbial growth. Freeze dryers operate under strict hygiene protocols, and air filtration systems protect the product from contamination. Because instant coffee is shelf-stable, maintaining low moisture levels is critical to preventing spoilage. Sustainability plays an increasing role in instant coffee production. Energy recovery systems capture heat from roasting and evaporation stages. Water used in extraction is carefully managed and reused where possible. Spent coffee grounds are repurposed rather than discarded. Some manufacturers invest in renewable energy to offset the energy demands of freeze drying. What makes instant coffee manufacturing remarkable is the challenge of preserving flavor while removing nearly all water. Coffee is chemically complex and highly sensitive to heat and oxygen. Transforming a freshly brewed beverage into a dry, shelf-stable crystal and then back into a drink with hot water requires precise control at every step. From roasted beans and industrial grinders to extraction columns, evaporators, freeze dryers, aroma recovery systems, and high-speed packaging lines. Instant coffee production is a carefully synchronized operation designed for consistency at global scale. And that is how instant coffee is made: brewed, concentrated, frozen, dried, aromatized, and packaged. transforming roasted coffee beans into freeze-dried crystals ready to dissolve in seconds. Thanks for watching The How Factory.